Okay, in this film I'm going to talk about the normal probability distribution. We've already talked about the binomial probability distribution. This is another type of probability distribution which you need to know about and can calculate probabilities for. So in this video I'm going to try and answer 4 questions. What is the normal probability distribution and what properties does it have? What notation do we use to describe the normal probability distribution? How do I calculate probabilities using the normal probability distribution? And I'm going to show you using the TI-NSPIRE. And given a probability, how do I find a value? Okay, let's try and answer the first question, which is what is the normal distribution? Well, it's a way of representing or modeling random continuous data. For example, weights of newborn babies, or heights of adult males, for example, in a certain country. If we were to say we had a variable x, it could be weight, for example, has to be a continuous variable, so we can't have we can have decimal answers, not just whole number answers, and we plot the frequency, so how many males of a certain height. We would see the distribution would be shaped like this. We call this the bell curve or a Gaussian curve. It's symmetrical about the mean value, which we call mu. So most males would have a mean height, and it has a certain spread. So it's not everyone has the same height. So there are some people with who are shorter, and there's some people which are taller. And the spread is defined by sigma, which is the standard deviation. And apart from being symmetrical about the mean, one of the properties of the normal probability distribution is that if I was to go one standard deviation either side of the mean and work out the percentage of the population which is between this value and this value, I would actually find 68% of the population within here. Okay, that's one of the properties. However, if I go two standard deviations away from the mean, taking in more of the population, I find that this green area, all of this here, represents 95% of the population, I believe. And if we go 3 standard deviations either side of the mean, the area under that curve would encapsulate 99.7% of the population. Let's go on to the next question. So question 2 was, what's the notation for the normal probability distribution? So just like as a reminder, for the binomial, we use this. If a variable x was binomially distributed, we wrote x is binomially distributed with a number of trials n and a probability of success p. For the normal distribution, if x is normally distributed, we write x is normally distributed with a mean mu and a variance sigma squared. So we have to know the mean of our data, and we have to know the standard deviation, and then square it in order to find the variance. So for example, I might have, let's say, let x be heights of adult males, with a mean, I don't know, 180, I'm just making up these values, 180 centimeters, and standard deviation 20 centimeters. Then I could model x using the normal distribution of a mean of 180 and a variance of 20 squared. Okay, so question 3. Let's say we have a normally distributed variable x with a mean of 180 and a standard deviation 20. Then what is the probability of finding something in the sample which has a value of less than 163? What's the probability of randomly selecting a something from the sample with a value of greater than 175, or what's the probability of randomly selecting something from our sample with a weight or a value of x between 170 and 190? Now you'll only need to use technology to solve this in math applications. So you take out your calculator, you go to a new calculator window, you click on Menu, Probability, Distributions, and you'll only be using the normal CDF. If you have a value which is less than or equal to a certain number, your lower bound is going to have to be this number, the smallest number you can get. For the upper bound, you take the value given, which will be 163. Your mu, which is your mean, is going to be 180, and the standard deviation is 20, and you click OK. So we get out a value of 0.198 to 3 sig figs. Now let's do B. We want to find the probability of x being greater than or equal to 175. We go to Menu, Probability, Distributions, Normal CDF. The lower bound will be 175 this time. The upper bound, we want to have as large a value as possible. To do that, we press 9 EE and then 999. The mean will be 180 and the standard deviation 20 again, and then click OK. We get out a probability of 0.599 to 3 sig figs. So what does this mean? This will mean that roughly 20% or 19.8% of the population has a value, let's say it's a weight or a height rather, of less than 163. In this case, 59.9% of our population would have a height greater than 175. To find two values between the probability of the variable being between two values, you go to Menu, probability distributions, normal CDF. The lower bound will be 170, upper bound 190, mean of 180, and a standard deviation of 20.383. So there's a 38.3% chance of finding a height between 170 and 190. Now let's try and answer question 4. How do we find a value given that we have the mean, the standard deviation, and a probability? So let's say we have a variable which is normally distributed with a mean of 180 and a standard deviation of 20, and we're told that above a certain value x we find 10% of the population, but we don't know what this value x is. We want to find that. Well, we can use the calculator, because using the function inverse normal, we can find out this value, because the inverse normal function tells us, can find the value given a probability which is less than the certain value. So first I have to find out the probability in the left hand side of the tail, if you like. So the probability is going to be 1 minus 0.1, because this is the complementary event to that. So the probability of finding the value less than or equal to x is going to be 0.9. Then I go to my calculator, I plug in menu, probability, distributions, and now inverse normal. I put in, as the area, I put in the area to the left of the value that I'm looking for, in this case 0.9, because remember the area under the curve is the probability. I put in the mean, in this case I'm given 180, and the standard deviation which I'm given is 20, and press OK. And then I can find, the calculator has basically told me that this value here is 206. So 10% of the population has a value of x which is larger than 206. So to find that, I use the inverse normal function.